Hey, geometry. We're going to continue our talk about 3D figures with, today we're talking about volume. Specifically, we're going to look at volume of two shapes. One is this rectangular prism, right? So think about filling this up with water or filling it up with rice, or just like in our discussion post today, how many bricks might fit in this entire cylinder. And we'll also be talking about triangular prisms. So remember, prisms are bases, same bases on the top and the bottom, or same figures on the top and the bottom making bases. Here is our formula for finding volume of a prism. Volume is the big base area times the height. So if I were to think about what this looks like on a rectangular prism, draw this out really quickly. That big base area, the base area is the area of the base, right? So that's what that large letter B stands for. That means base area. And then the H value stands for the height of the figure. So when we look at triangular prisms, sometimes we use height as height of the triangle, but in this case, we're going to be using H as in height of the figure. So don't get those confused. So let's take a couple of glances at some examples here. So here's one example from your notes. This is in the extra practice number 1. We have this figure, it's a triangle, right? Triangular prism. So I'll draw it as best I can. Drawing it out really helps. And the height of the triangle is 1.5. This is 3 centimeters. And then this is 5 centimeters. So even though it's sitting down, this bottom part is not your base, because you don't have 2 of them, right? So we know it's not a rectangular prism because you don't have 2 of them opposite each other. What we do have is these triangles here. So that's how we know it's a triangular prism. So I'm going to call this, I know it's a triangular prism. So I know that when I find the base area, the base is a triangle. So when I say volume equals big B times H, big B is base, and I want to find the base area of a triangle. Well, the area of a triangle is half the base times the height, right? And I put a little b there because that's the base of the triangle. So 1/2 the base of the triangle times the height of the figure. Let's write all this out. 1/2 the base of the triangle is 3. The height of the triangle is 1.5. And then the height of the figure, I'm going to highlight that in orange just so we can kind of see it. The height of the figure is that 5. Really helps to use colors, especially when we have same letters going on. So the height of the figure is 5. So let's use our calculator to determine the volume of this triangular base. So I have 1 divided by 2 times 3 times 1.5 times 5. So the volume of this triangular prism is 11.25 centimeters cubed. So think area is squared, volume is cubed because I'm filling it in, right? It's 3D. So think, yeah, if it's 2D, I'm finding it's squared, right? And if it's 3D, it's cubed. Little hint. All right, here's our next example. This is on the back page, exercises 7 and 8. We're going to do number 8 here. Oh, no, sorry, number 5. want to do that one? Yeah, let's do number 5. We have a rectangular prism, looks like this. Takes me a little bit. Oh, you can't see that. Let's move it down. This is 18 centimeters. This is Y, and this is 3.5 centimeters, right? It tells me that the volume is 661.5 centimeters cubed. There's our cubed again. And it tells me, let's find the value of Y. So looking back, I know that volume is the base area times the height. In this case, my base, I'll highlight it in yellow here. My base is a rectangle, right? It's actually sitting on the base this time. Really, for rectangular prism, you can use either one of the rectangles as your base because they do all repeat and they could actually sit on the bases, but we'll use this bottom one here. So the base here is a rectangle, and the base area of a rectangle is length times width, right? And then we're going to multiply the height of the figure on the end of that. So here's our height of the figure. We'll highlight it. There we go. All right. So if I know the volume is 661.5 centimeters cubed, I'm going to plug in my values now. Volume is 661.5 centimeters cubed. My length of my figure is 18. My width is Y, and the height of the figure is 3.5. Right, so this is kind of messy right here. So we're going to put these together. I'm going to multiply 18 and 3.5. 3.5 is 63. So I have 661.5 equals 63y. Now I can go ahead and solve it just like an equation. I'm going to divide by 63, and that'll give us our y values. So 661.5 divided by 63 is 10.5. So that is my missing value here. And that makes sense. So I want to think, does this logically make sense that this value is 10.5 when this is 18 and this is 3? Yeah, it does. That's a reasonable number for this value. All right, let's keep going. So that's finding missing side length. Let's look at our next example here. And I have describe how the change affects the volume of the prism or cylinder. I'll show you what I'm reading. Describe how the change affects the volume of the prism or the cylinder when you multiply the length and width by 1/6. So let's see. I want to see what happens when I change the value. So this is number 8, right? So we have a rectangular prism, kind of like the last one that we saw. And it says 18 centimeters, 12 centimeters, and 3 centimeters. Well, it says describe the change. Well, I need to know what the first volume is to see what the change of the second volume is going to be when I do the changes. So if I know that volume equals base area times height, let's see what we got. My base area is this one down here, helps to add color. And then my height is here, right? So height, base area. In this case, my base is a rectangle. So again, I have length times width, and then we'll multiply it by the height. So my length is 18, my width is 12, and my height is 3. So let's see what my volume is going to be. 18 times 12 times, 18 times 12 times 3 is 648 centimeters cubed. So now I want to know, oh, that's kind of blurry. All right, there we go. What happens when we multiply the length and the width by 1/6? That means I'm going to change this number and this number, right? So let's create a new rectangular prism. Ooh, just so we can see what those new values are going to be. We can start a little bit fresh. So let's see. This is 18. If I multiply it by 1/6, it's really dividing by 6, right? So it turns into a 3 centimeters. If I multiply 12 times 1/6, it's really dividing by 6, so I get a 2. We can check it too. Let's check it. I just want to prove it to you. 18 times 1 divided by 6, ta-da, 3. 12 times 1 divided by 6, ta-da, 2. And then we still have a 3. So I'm going to follow the same formula that we did over here. Length times width times height. Length is now 3. Width is now 2. And then height stayed at 3. It didn't say anything about changing that. So let's see what happens to the volume. 3 times 2 times 3, and we could probably do that in our heads, and we get 18. So I want to know if the length and width are 1/6, what is the volume? So let's see what this ratio is when I put 18 over 648. It's 0.2. So let's see if I do it the other way. Divided by 18. 36. So it's 1/36. Interesting, right? So look at this. The side lengths are in a ratio of 1/6. And the volumes are in a ratio of 1/36. So squared. Very interesting, right? All right, so that was that question on number 8. That the change went from 1 to 1/6 to 1/36. All right, so today we have a quiz over the surface area and the volume. I think you're going to do great, and we'll do that together in class. See you soon.